First of all, thank you, uh, Sadnan and Shakir and everybody else who just pull up the effort and bring all the community together. Thank you for the opportunity. I'm really excited to share my session here. Let me just quickly share my PowerPoint presentation so we can quickly go through what I have today to present and how we can make this session super interesting. And let me just swap this. So yeah, that's better. As you guys know that my name is Osama Wahab Khan. I know it's a very long name. You can just call me Osama, and I'm Microsoft Most Valuable Professional, certified trainer, and blah blah blah. I have done tons of certifications and learning around AI. I have attended MicroMasters at MIT for deep learning and AI last year. So I'm very excited to share the knowledge that I'm able to gain around the space of AI and generative LLMs or generative AI. Today, I'm going to talk about one of the interesting topic in the world of generative AI or LLMs, large language models. Uh, how to control hallucinations, how to provide them a latest information which they don't have, and how to work with something we call RAG, retrieval augmented generation. It's a really holy grail of the whole AI development going on, and it has everything that one's need to build their enterprise grade application. And this pattern is one of the most common and widely adopted pattern across AI implementation in the world, not only just for generative AI, even for other aspects as well. So first of all, what is AI in a highest level of terms out there? We recognize AI as mimicking human cognitive services out there. So we try to use a mimic through computers the human intelligence. So like the way we see, we recognize objects, way we create content, understand, analyzing, object deduction, and much more. And this particular practice is a very wide domain. And one of the subset of machine AI is machine learning, where we basically trained computers on a certain data that they can make intelligent decisions out there. They can able to find patterns as well. We trained machine learning models that are becomes enough efficient so they can learn from the pattern and deduct something new which they have never been showcased to earlier. This is something very exciting, and machine learning is a very large discipline. And nowadays, there's a tons of work going on in this particular discipline. And one of the advancement in machine learning is called deep learning. Deep learning is building machine learning models, but based on neural network, the way that brain works. It's tried to mimic the brain neural network work, the way the brain process information or generate any kind of decisions or outputs. Same pattern, we have learned that how we can create these neural networks by different techniques, and we can train these neural network on a very large amount of data apparently, and be able to get an output based on earlier findings. So we trained our weights and bias upon that, and when we provide them a neural output which the model is not being trained on it able to analyze on previously deducted patterns. It's not magic. It's a total mathematics out there, and don't want to keep geek into it. And one of the furthermore advancement in this field, which make a buzz last year, especially in the last 2 years, it's called generative AI. Generative AI, it's a, you can say, is a what? This is something that term is being exaggerated on a very large scale, but it's all over the place. It's all over the place, especially if you're a Microsoft folk who love to walk around Microsoft technologies. You have heard of this word in every single product of them. And all over the internet, after ChatGPT showcased their large language model, this thing really get ignited. And what is generative AI? In past, we have the AI that are quite efficient, but they're normally single purpose AI or they're weak AI, I must say. And they are the AI in past that we have used are usually analyzing, deducting, or classifying content. This particular type of AI able to generate new content. So we train this particular kind of model on a very large scale data set. So they're able to produce code, text, videos, images, and more. And so they can now understand the language and able to generate a relevant content. And the generative AI is just getting out of the hand, honestly. So from text classification, code generations, image generation, semantic search, dialogue-based bots, idea creations, semantic analysis, and much more than that. So from text summarization to from Copilot to building an advanced analytical compliance applications can be possible through this new concept of generative AI. Concept is very simple. We pass instruction to machines and to our large language models or any other model, AI model, which is capable to generate content like diffusion models. And based on their training, based on their capabilities, they will generate something. Output will call completion. So might you already have heard of this word plenty more time, LLMs. So what is this large language models? LLMs is a type of a machine learning model that technically been trained on an enormous amount of data. When I say enormous amount of data, we're talking about here petabytes of data. We're talking about here a trillion parameters. Now we have these large language models which has been trained over trillion parameters. In earlier days, we have seen large language models to limit around 100 to 350 million parameters. But after when we have this got this advanced accelerated computing capability through NVIDIA A1 GPUs, we able to train machines and our models on a very large scale of data. We able to use the large in-memory processing that help us to create and build these expensive models as well. And these models definitely use huge amount of data, which require tons of computing, which require tons of data processing and compliance on top of it. And controlling those aspects in neural network, it's not an easy task. But why this get ignited? So some time back, I'm going to talk about that one in a couple of seconds. Uh, so these large language models sometimes referred as our foundational model as well. Since you guys have known now that these large language model is being trained on a very large amount of public data, that data that has been collected from public internet, which means that it has access literally all over the internet. So if you look for the OpenAI model ChatGPT 4 or 4 Turbo, they claim it's more than 1 trillion parameters, which are approximately 25 to 35 petabytes of data. It means across all the internet. But again, only the internet-based resources that being used, the public information is being used to create these machine learning models. Even they are very expensive to train. There are approximately millions of dollars required and hundreds and thousands of man hours required to build these kind of expensive models. Not just creation of them, training is one of the most expensive part. And we can't train them every day. And many organizations don't have infrastructure to do that. So these fundamental models are sometimes treated as a fundamental models, which based on algorithm called transformers, which been introduced by Google in 2014 and continues efforts on it till 2017, which we see where we see the actual algorithm. And after that, many organizations, including OpenAI, Google Meta, and many others, has adopted the same algorithm to implement their own implementation of this new model that called transformer-based large language model, which gave a capability to parallel process data and understand the semantic meaning of the words in a sentence and also their order. Because of this advanced capability, now we can tell machines and machine can understand the semantics of your sentence and able to generate content accordingly. And once we have these foundational models available, so we use these models to create low stream applications. We try to use this foundational model to fine tune it further or create applications on top of it, like creating bots, semantic analysis, extracting information, medical record management systems, and list goes on. You guys might seen Midjourney or many image recognition software as well. All this make it possible because of this model that called Transformer, which introduced by Google in 2017 and then adopted by ChatGPT, OpenAI, with the first model they have showcased 175 billion parameters, and they continuously progress on with the larger data sets and more optimization. So today we have 1 trillion parameters, 1 trillion parameters dataset models are available, which is super expensive and to basically reproduce it. But these models are so efficient, they can do so many tasks, they can analyze tasks, they can generate text, they can summarize text, they can extract text. So one model, they have a multiple activities. It still is a weak AI, but still is moving toward AGI. And we can build applications and achieve different goals out there. I think so. You guys have seen lots. If you're in this demo, that means you already have seen the LLMs, or you all might have seen some of demos that Microsoft has showcased through their client applications, or like the Copilots or ChatGPT softwares, or build your own GPTs. The concept of these models, how you work with them, it's very simple. You provide the instruction in a plain text in English or in Arabic or in Urdu. So you can provide them a text in a plain English or in plain input, and that input will be provided in an interface of large language models, where large language model based on its existing learning able to understand the structure of the question or the request and then process an output. And you can instruct what kind of output you want from them. So the better you write the text, the better the outcome will be. However, these large language models have lots of shortcomings, which we're going to talk about shortly. And so the concept behind this whole phenomena, we call them prompt engineering. Prompt engineering means the input that you submit to the large language model in order to generate an output, it called prompt. The request that you send to the large language models, normally referred term as called prompt. Prompt is a listative and organized structured instruction that you pass to the large language model. The better the instruction and more examples in it, the large language model able to better understand it and generate a much more accurate, much more relevant content for you. And the result that generated by large language models are called completion. So here's one example that painting on a dog, painting on a flying dog, and that will be my prompt. I send that one to AI neural network, which is LLM, and that probably it's going to generate something like that. And this particular concept across generative AI is very common. This is one example that I can ask AI, write a letter to my teacher for missing class. So same thing you can do within a Copilot. Might you have seen so many examples in past. If you guys have seen Bing GPTs, let me quickly show you a short example, real-time example. So you go here in a Copilot. Okay, let's say, let me ask a question here. So here we are, and we can just click here. We can say, write a poem for Tech Days, Pakistan. And I can just, so this particular instruction, which I have passed, it's called prompt. That's the prompt that I have injected through the client application. It's been served back to the LLMs, and LLM will going to process that and generate an output. The output will call completion. And in a couple of seconds, you'll see we got a pretty nice poem out there. So my Shakar and Adnan Bhai can use that. So Shakar Bhai, you can just grab from this and you can just put them on your Twitter. Might look so fun. See, it's very cool rhymes. And so that particular way that we can able to generate content. And the more better illustrative you define instructions, you're able to generate things. It's very difficult for developer to handle these kind of models out there. In past, they were used to work with the syntactic development. Now, the development with a large language model of building generative AI applications has been completely changed towards semantic syntaxual models out there. So they have to become more understand, they have to more adaptive towards this prompt engineering, that how they can feed the better information to these models so get their desired outputs. OpenAI, it's an company that used to be a private company and still private company. They used to be a open source, but now they are closed source, started by Elon and Sam Altman. Now, most of their stakes is owned by Microsoft and some other partners, and now is a profitable company, no longer no profit organization, which means it's like any other company who provides services and they build models. Microsoft has a very deep relationship with them, and they have a proprietary access over these models that are generated by OpenAI, so they can use in their products. And you have seen these models have been heavily integrated across Microsoft product, from Windows to Office to Teams and everywhere where they can. So they offer multiple models which have a different capabilities. GPT-4 is a multi-model, which means that a single model can generate image, text, audio, videos, in fact, and take an input from multiple dimensions, not only text only. In past, we have a text-based model, that's GPT-4, GPT-3, and we have Whisper, that's a voice model that we have also Okra. So we have multiple models. They perform different kind of tasks. They are optimized for a specific task. For example, embedding model. So embedding ADA model. They have an ADA. That's a term that use it out there. They generate for vector embeddings. DALL-E is used for image generation, and it is also diffusion model. We're not going deep into the LLMs, and since our focus is more on RAG. And so the problem with the LLM can hallucinate things. When they don't have information or when they don't find relevance, even they can create their own file, like just like kids. They can make their own stories. And that's very dangerous. If you're relying on a machine that you want them to be create something if they're not aware of it, or that's not true, or might be biased or racist as well. How you can overcome that challenge? by providing them additional knowledge what they've been trained on it. One option is fine-tuning. Fine-tuning means adding the new set of parameter, adding a subset of a new learning on top of what they already have learned. So you don't need to train 1 trillion parameters again. You can just train a few thousand, a few 100,000 parameters and add them upon it, and then let them work together. Even you're training a smaller set of data, still you have to adjust the weights, which basically make the whole process time consuming and expensive and difficult to handle it. So in some areas, fine-tuning can be a nice choice when you want your certain LLM to be specialized for specific kind of thing. Let's say medical domains, where they want to be a domain-specific knowledge to be gained and single shot to work better. Enhanced context relevance. So they don't sometimes lose the context relevance. Why? They don't have a real-time knowledge. They've been trained on a data, and after that, whatever the knowledge is being brought up into the world, they are not aware of it. They've only been trained on a public data sets. So they're not aware of private information that's stored in your databases or in your repositories like OneDrive. How we can overcome them? As I said, that fine-tuning is one option, but it's expensive. Another option is RAG. RAG stands for retrieval augmented generation. In this particular process, we use another embedding model where we convert the text into vector embedding, which basically a numeric representation of a text in a high dimensional space. And they use a cosine similarity concept behind the scenes to basically find the closest object or closest vector based on the QD, and they're able to extract this information. So it's a more efficient semantic way of searching data. So what we do normally, we take our data sets, we basically break down these data sets into smaller chunks, convert them into vector embeddings. Vector embeddings are something like a space where the high dimensional space where one thing is closer to another, which have more close relevance, but in a high dimensional space. And this is how the workflow looks like. So we create those particular data sets and convert them into vector embeddings and then store them into vector databases. Upon our request, when we ask LLMs to perform some task, first this question sent to the LLM, they convert them into vector embeddings, and then she send back this vector embeddings to databases, where databases do the query based on this new vector and match with the relevant vector they already have stored. And then they send back the relevant delta information, the smaller piece of information, which is more relevant to your question. And then we have this additional knowledge that we need to provide. And we have also the previous knowledge that the LLM already have. When we combine both of them, results are more accurate, more updated, and it can also provide information from your real-time databases. So why use RAG? First of all, it provides a supplement of a data as direct as prompt. So it can help you to inject a new prompt or new data that has been stored in your private repositories. RAG allow business to achieve a customized solution that can achieve their more accuracy and optimization by learning from their data, talking to your data, and also precising and optimizing the result of LLMs. They increase the efficiency and accuracy of results. In some case, we use this RAG model to control the hallucinations as well, or stopping them not to do things wrong. So the process is not that complicated. So you took your data sets, you use the libraries for building up pipelines that can be a Python. We try to read the text and break it down into smaller chunks because every LLM have a limitation that how much size of input text they can accept it, and that called tokenization, number of tokens. So many LLMs cannot process more, let's say, mostly the embedding models cannot process more than 5 to 10,000 tokens. And so if the text size is more than 5,000 words, might be the process will not able to follow or get an error. So that's why we break down our whole text into smaller chunks. And slowly we send this particular information to the LLM model, get the result back. Once we get the result back, it's usually in a numeric code. And once we have this numeric code, we store this numeric code into vector indexed databases, like a database that's designed for vector. And we store that. So when we perform a query, it's a vector-based query. So it understands that apple is close to orange, so it basically fetch the orange as well. So it's not keyword-based search out there. It's not a keyword-based query. It's more semantic query. That basically brings the whole charm into picture. If I'm going very fast, I'm sorry, because I have very less time. So I want to just make sure that I can cover maximum I can. You guys can grab me on conversation with me or LinkedIn or Twitter. I'd love to talk about it. And here is a very nice process example at how technically RAG process works. So it's a two-part process. The part one, building a pipeline to store or create a vector index that you can see on the bottom. So you have your documents. It can be in blob storage. It can be anywhere. Then you basically extract the text. If these documents consist of images, might you want to run an OCR or something else that bring the text out of it. Once the text is in out of it, you do a chunking strategy that how much smaller chunks that you can do. It could have really impact on your implementations as well. So you can just and your retrieval as well, the accuracy as well. So you have to very really decisively analyze that what size of chunk will be the best for your needs. And then you pass these chunks to LLMs. This is called embedding models. They convert text into vector embeddings, which is basically high dimensional space relevance by using cosine similarity. So they send this into this LLM models and it generate them in a vector embeddings. And then we use this vector embedding to store them in spatial databases that called vector stores. And now our data, our whole text is converted and stored in a high dimensional space in these vector databases. Anytime we can send them an apple. So anything that is closely relevant to apple also bring into the query as well. So it might send me the oranges, it will send me the food or rounded food, even the balls. So it know that which word is far and which is close in a multi-dimension. Don't picturize that one in a 2-dimension. Think of it thousands of dimensions. I know it's difficult. So second, you have the application layer, that call an orchestration layer, where we try basically to send our questions. So here we basically submit our standalone questions. So here we basically submit our standalone question that can be a general prompt. Let's say, what will be the last year what was the last year revenue for JP Morgan? And I have information here, and that's a public info, it's private information. So what my model will do, my model will first of all use this particular questions and send them to LLM and convert this text into vector embedding and then send this one to the vector database to perform vector search or semantic search, which means they took each vector embedding and find a relevant match in a high dimensional space, which able to extract a more semantic, more relevant, more summarized information than a keyword-based search. And once this particular search is done, it basically retrieve the documents. Now you have a relevant knowledge what question has already been asked about it. And then this information will be injected along with your question and sent back to the LLM. Now this time LLM have not a basic prompt. It have a question that you have ask for it. It has a private information that might have contained in a more detailed answer. And here it's going to summarize and aggregate all other things. It's just going to construct the question or answer, construct the answer with the help of these newly created documents or provided document and its own knowledge. And the result will be able to more summarizedly, more accurately able to answer things which general LLMs are not aware of it. Why? Because by defaultly, they don't have access over internet. By defaultly, they have information that only the point where they've been trained on it. And that's why this particular process becomes so important. This is one of the anatomy of an application out there. So we have an UX, we use an AI orchestrators like in a LangChain. There are different libraries out there where the questions will receive. First, they send for the query, they get the knowledge. This is basically semantic search or hybrid search, and the knowledge and their questions added together and sent back to the large language model and wait for the return. If you use a Microsoft Copilot, it's the same thing. Microsoft uses the same methods out there. So documents, you create an index by using API, perform on compute, and put them on vector databases. App request happens, you call the ChatGPT and perform their questions out there, perform embedding, convert the embedding, send the embedding back to the vector database, get the relevant documents, and just send it back to ChatGPT to get the correct answer based on new knowledge and return the response. In order to automate this whole process, there are lots of tools that are available. Some of the most important components are data sources. If data sources are structured or unstructured, you have to apply a whole data engineering mechanics to it. That how you're going to process the data, which can convert into chunks. Second, a pipeline strategy, indexing strategy. You need to clean an OCR data, perform data chunking, and start indexing. How this index will be updated and which particular database you will use for that. You have to pick the right embedding model that can basically support a various aspect of applications. OpenAI have ADA model, but on open source Hugging Face, there are hundreds of models are available based on cost, compliance requirement. You can pick one model that can convert your text into vectors. And based on that vector embedding, and you also have to think of it, that particular vector embedding size should be supported by the database, the one where you want to store data. There are 1024 dimensional size for the by default for OpenAI vectors, but there are a few models that have a lower vector or more composed vectors as well. And these data, where the data store is called vector databases. And here are the database they created, the index they created that called vector indexes. And the query that we run to return the results, we call retrieval query. And AI orchestrators are the tool that help us to build this whole application. These are the libraries like LangChain or semantic kernels that help us to build whole this complex architecture in a much more organized way. And the response LLM does not need to be compatible with an embedding ones, because we never send embeddings to these response LLMs out there, like ChatGPT-4, ChatGPT 3.5, Llama, or any other ones. They just receive a plain text end of the day. So literally, they can be anything. So as I said, the embedding are the vector array or numbers that represent the meaning of the in context of token that represented by the model in a very high dimensional space. And here I have put the links. These presentations will be available for you after the session. You can see here the illustration that I can write the text. It will be converted into the vector by embedding models, and it will be going to present like these numeric databases out there. And how this basically works, you can see that in a two-dimensional picture that basketball, and baseballs are together. They are in like in a close cluster. They're close to each other. So when the query will come, the semantic will able to understand if they have to pick a ball, they could be this one or this one. So they have a longer or shorter distance, they're able to pick the right relevance areas out there. So if you have, for example, an apple, we're going to put it. So definitely apple is in a round figure. So I could put it apple here, but it's at the same time, it's a fruit. And also it's not anything like that. So I might put an apple somewhere here. Okay, might be I put an apple somewhere here. So when I query an apple, it shows some relationship within a fruit, and also shows some relationship or some dimensionality connection within a round figures as well. So since it's not completely round, so I might want to put them closer to fruit out there, which make more sense. And same way, the other things are there. But think of that one not in 2 dimension, think of that one in a very high dimensional space. So that's why these LLM models are also working in a similar fashion behind the scenes. So consider them the way LLM train their weight and bias is the way they can calculate their weights. It's the same way of extracting those weights or storing the kind of like those weights into databases so they can gain this knowledge on the fly. So vector databases are the data. Yeah, we are out of time.
Yeah, exactly.
Give me 5 more minutes only. I'll just wrap it up.
Okay.
Not thank you. Sorry. So we already talked about vector databases, okay? And I wish I could have more time. One more important thing that Microsoft offered 3 vector database options: Azure Search, Cosmos DB, and also Pinecone. Pinecone is a world-leading vector database, but you could use vector database from Cosmos DB, and which basically called MongoDB or Postgres. So there are 2 databases are available at this moment that can provide you great scalability, and you can store tons of data out there, and you can directly integrate these products with Azure Search and OpenAI. If you guys, since I am run out of time, and what I have done, I have earlier created this whole notebook for you guys, and I plan to just run this demo, but it's a very extensive demo. It might take a longer time. Now, what I will do, I will record a video for that demo and put them on internet. So anybody who's interested, they can not only grab these files from my Twitter, and I will give the file to Adnan Bhai and the team. They will going to put that one on their repository as well. So you guys can run that one at your own. It have all the descriptions available that one need to run this particular demo out there. And this is one sample that this is a sample that how the vectors are being created. This is a text that I have, and it convert them into this kind of vector embedding. And I can upload and store them into MongoDB. And I have put the whole code for the MongoDB here, that how you can upload them and how you can perform the query. I wish I could have more time so I can show you end-to-end demo that how it works. But if you have ever seen a Microsoft Copilot that working in Word or Excel or PowerPoint, it worked absolutely in the same fashion. I mean, it's use a data that already available. So, and they can just provide you on the fly. I hope so. You like this short session. I know it's very fast. It's going very fast, and we don't have much time to do. We have some technical difficulties earlier. I would like to thank one more time everybody else who's here and who bring all this effort to make this thing live. And if you guys want, this is my Twitter handler under Osama Wahab Khan. And feel free to ping me anytime if anyone can pick that one on internet. Or anyone can put them on the chat. I don't know how to put it, but feel free guys to catch me here on Twitter. If you have any questions, this account only been used for technical purposes, no religious political discussions, only tech. So if you guys want, you can have a conversation with me anytime. And I will be in Riyadh and Oman and in Seattle next week, next couple of weeks. So if you guys stop by Leap or anywhere else, feel free to say hi. And if you want to talk about AI, I'm always in. Thank you for all, and thank you for time, and thank you for giving me extra 5 minutes as well. Thank you guys. Have a good day.
Thank you so much, Osama.